Water filters for Haiti.
Hi, I'm Matthew Shumack, and I'm a background researcher.
Hi, I'm Luis Hernandez, and I'm the designer.
I'm Bryce Humphrey, and I'm the chair of the Ethics and Expense Committee.
I'm Justin Frederick, and I'm the production manager.
I'm Tay Shen, and I am the video editor.
And I'm Matthew Connor, and I served as the team manager for the project.
Haiti is the poorest country in the Western Hemisphere, and as a result, many people live in complete poverty. There is a weak structure for aid from the Haitian government, and reoccurring natural disasters continually wreak havoc on an already stressed infrastructure. One of the major problems for this country is the lack of access to clean water, particularly for people living in rural areas. 70% of the population lack access to clean drinking water. Unclean water results in the spread of diseases and waterborne illnesses that ravage the population. Our proposal is to bring clean water to Haitian villages using a biosand filter, which will be a cheap, effective, and culturally appropriate solution to the lack of clean water in Haiti.
In this section, we'll be looking at the design of the filter. We thought that it had to have both practical and economically feasible to ever have a chance of getting to Haiti. The outer shell of the biosand filter could be built from either concrete or metal, which both of these materials are readily available in Haiti. We have inside the outer shell, we have various layers of sand and gravel. These help to filter out the contaminants in the water. The top layer, we have a bio layer. This is used for destroying all the harmful pathogens that are present inside the water. Then we have a layer of fine sand, and then we get to the coarse aggregate. Now, all these together help purify the water greatly. And now we look at the technical specs of this. The filter is designed to hold just around 64 gallons of water and would be producing about 500 gallons of water per day. As for the technical specs, we have 17 inches in length by 17 inches wide by 51 inches tall, which would give us a volume of about 64 gallons. While also we constructed a base for this filter to go on top of. The base is 51 inches by 8 inches. So we have a steady and firm base to put this huge weight on. The reason why we use these specs is because we're thinking about putting just around 2 filters in each community, and each community would have just around 1,000 people. So we calculated that each filter would be producing just around 500 gallons. So once we have 2 filters, that'd be producing around 1,000 gallons. And this meets the average of water drinking, which is just around a gallon of water. So their needs of drinking would be fulfilled with these 2 filters. And the reason why we chose these materials to go inside is because, again, they're readily available, like the concrete and the metal, but also the materials that go inside, the coarse aggregate and the fine sands. This can be easily obtained in many parts of the world, and because of that reason, we chose to use these materials. They are easy to find and easy to purchase as well. We're thinking about having local labor to construct these filters. This would help accelerate their economy because we're injecting money into their economy instead of having to outsource and actually ship all these materials into their society.
In this part, we will be examining the benefits of our particular design and also how our filter will help the people of Haiti. As we mentioned before, the main reason why we chose this design is because it is very simple and cost effective. It requires no chemicals or complex processes to function, and it is quick and easy to build. By using this design, we can keep costs low and construct filters for many villages. Despite being cheap, the system still removes nearly all of the harmful pathogens that are in the dirty water. By ensuring that the water is purified, we greatly improve the health of the Haitians that we serve. The benefits of clean water for the Haitians are immense. Many diseases that stem from dirty water, such as typhoid, hepatitis, and chronic diarrhea, can be eliminated. This decreases the infant mortality rate and increases the health and well-being of all the nearby residents. In addition, clean water is used for more than just drinking. It is also used for cooking and bathing as well. Our durable and long-lasting solution will greatly improve the health and well-being of the families and children that we serve.
With regards to the cost of this project, our filters are cheap and easy to make. The resources should keep the cost low. We are estimating around $500 per filter based off of similar design. Since we'll be able to provide 400 filters, the cost of the materials alone should be around $200,000. However, workers would also have to be hired in order to build the filter. Minimum wage in Haiti is 225 gourds per day, or $5.61. However, as we want to help boost the economy, we will provide double the wage per day, $11.22. Assuming a team of 5 to 10 people and about a week to make each filter, costs range from about $150,000 to $300,000 total for worker costs. This means the total cost will be around $350,000 to $500,000 total.
As previously mentioned beforehand, one of the main advantages to our solution is the simplicity of its construction. When manufacturing a biosand filter, there are two main stages of production, both of which involve a waiting period before the next phase can commence. In the first stage, the foundation of the filter is dug and the container is created by pouring concrete into the mold. While this step can be done in 2 days, it will take at least a week for the concrete to solidify so that it can bear the necessary load. After this period has passed, the concrete will be suitable for use. Note that it will continue to increase in strength greatly throughout the first month. In the second stage of production, the biolayer foundation is added, consisting of the washed sand and gravel. Fortunately, these materials can be obtained and washed throughout the week that the concrete is solidifying and can therefore be ready when the container is complete. Once the biolayer is added, water is poured into the system to help the layer mature. This can take 1 to 3 weeks, at which point the system will be capable of filtering water to a level suitable for drinking. Therefore, though the biosand filter may not be ready for a month, the majority of the labor can be completed within several days. This means the production team does not have to remain to work on a single filter and can leave after each step is completed, eventually returning to finish the project, of course. Theoretically, depending on how quickly the filters mature, a team can work on 5 or more biosand filters at once.
In the interest of helping out the local economy, we will try not to cut costs to a bare minimum. We intend to buy and source as many of our resources from Haiti as possible. This will provide the local residents a source of income and stimulate the local economy. This might increase the cost of filters a little, but will also cut out the cost of shipping the parts in from another country.
Traditional forms of monetary aid in Haiti usually fail due to the corrupt government. The aid is essentially stolen and is never used to benefit the local people. As a non-governmental organization, we have the ability to provide money and resources directly to the communities that need it. We can talk and plan directly with the local citizens and build positive relationships with those we serve. With this ability, we bypass the corruption and stabilize the economy from the bottom up, which benefits all the villages involved.
As stated above, the people of Haiti are in great need of clean water, as nearly 70% have no access to clean drinking water, with that statistic rising in rural areas. Clean water is critical to their survival and health, yet they have little ability or money to provide any for themselves. Therefore, our biosand filtration project proposes a solution that will help to improve the lives of hundreds of thousands of Haitians. Our filtration systems are reliable and durable enough to last, and cheap enough to be widely distributed. Furthermore, the affordability of the filters means that more can be installed, helping to virtually eliminate the need to travel between villages for clean water, and they allow for usage at whatever rate each village requires. For this project to succeed, we will need at least $350,000 to meet our initial goal of providing clean water access for 200,000 desperate Haitians, but hope to obtain enough funding to further provide for a country in tremendous need.